All right, turning it over to Dr. Nelson.
Okay, thank you, Linda and Carrie. Let me share my screen. Okay, hopefully, is that coming through okay?
Thank you.
Great, thank you. Okay, so I'll give a brief overview of the state of play with the PRESCIENT network. So to remind everybody, this is the PRESCIENT network with 11 recruitment centers across Australia, Europe, Asia, and now South America as well, with Orygen in Melbourne as the network hub. And we have a number of scientific partners involved in the network as well. There they go. RCSI, University of Groningen, and the University of Queensland and New South Wales. Okay, and this is the PRESCIENT network, represented in yellow, fits in within the larger AMP Schizophrenia Consortium. I don't think yellow was a deliberate choice when this slide was put together, but it's sort of appropriate because yellow is generally the color that Australia is represented in international sports. So that sort of fits quite nicely. Okay, so there have been a few changes in the network since the last annual meeting. Our Perth site was replaced by Cologne, with Joseph Kambeitz and Lana Kambeitz-Elankovic as PIs. And Amsterdam was initially replaced with Bari in Italy, but there were some difficulties with running the neuroimaging protocol on the scanner there. So thankfully, Santiago at the University of Chile with the PI of Pablo Ramos have come on board to replace the Amsterdam site. And I suppose the other major change has been the increase in healthy control sample size in Melbourne from 15 to 100 to enable more effective matching with the large CHR samples, so 400 plus to be recruited in Melbourne. All right, so here's a full list of the sites and recruitment targets at each site, just over 900 in total, with 250 healthy controls. This will probably strain people's eyes a little bit, difficult to make out, but it summarizes the structure and governance of the network. Again, just very briefly, a few changes since the last annual meeting. Kate Bucilli at Orygen has come on as the lead project manager. As I mentioned, the change in sites. Dr. Scott Clark has taken over from Dr. Paul Amminger as the fluid biospecimens lead for PRESCIENT. And Hanneke Wigman and Annie Ching have been sharing duties as leading our digital biomarkers work group. And also Dominic Dwyer has come on and joined the data analytics work group. Well, as Carrie's mentioned, there's been a lot of activity going on over the last year, all listed up on the slide here. I won't go through them all, but most recently there's been mock data collection at a number of first-tier sites, and we're actually we've booked in 4 participants now for the 24th and the 27th of this month, but we're waiting on the green light from DPAC before we go ahead and assess those participants or potential participants. A green light based on data transfer pipeline testing and some QC checking. But it's good to have a few people interested and booked in for those dates to be part of the study. Okay, so this is a summary of site progress. It'll be a staggered start with Melbourne kicking off recruitment, followed by the other sites listed up here, notably Copenhagen, Birmingham, and Adelaide will be due to start recruitment shortly after us in Melbourne. All right, so that's a quick overview of the research network. I thought just with the time I have left, I'll shift focus a little bit. So the AMP Schizophrenia Data Analysis Working Group has started meeting, chaired by Linda and Ofer Pasternak. And one of the things it got me thinking about, again, I suppose, was the heterogeneity issue, which is, of course, one of the challenges that AMP Schizophrenia aims to address, to use this array of biomarkers to pass the heterogeneity in CHR cohorts to identify characteristics and predictors of subgroups based on clinical outcome, the primary one being transition to psychosis. But I think, the heterogeneity, or at least the variability that can exist within these outcome subgroups often doesn't get much attention. Sometimes we can forget about that, including how the prediction models we develop may need to take that variability within these outcome subgroups into account. So just focusing on the transition subgroup, the blue group here, there is, of course, some heterogeneity in diagnostic outcome. I mean, not all of these cases receive a schizophrenia spectrum diagnosis. And there's variability in illness course as well. Of course, some will be in the first of many psychotic episodes. Others may only have a single mild psychotic episode. But there's also heterogeneity in mode of illness onset. And that's, of course, been known for a long time. I mean, of course, the acute versus gradual onset distinction in the schizophrenia literature. But it hasn't been examined that much in CHR samples. So the analysis I've got up on the slide here used group-based trajectory modeling of monthly clinical data to identify latent classes in CHR participants who transition to psychosis. And this is only a small sample. It's approximately 40 transition cases from a Melbourne CHR data set. But what we can see here, if you can see, okay, these boxes up here. So one group, I'm represented in green, shows this, sorry about my voice, shows a stable, then deterioration sort of trajectory, a sort of a slide into psychosis. And then we see another transition subgroup which shows this sort of initial improvement in symptomatology. So the line going down, these are total attenuated psychotic symptoms scores, so severity of APS, and then a reasonably sharp deterioration. The term psychotic break might even be appropriate, for this group here. They say, a reasonably sudden onset of psychosis after initial improvement. And then a small group here, small percentage, only 5%, who have very mild symptoms and then sort of tip into psychosis. Now, my point is that it may not be, that a single prediction model doesn't perform equally well, across these different types of transitions or modes of psychosis onset. There may actually be quite a lot to ask of a single prediction model. Of course, one of the things we have in AMP schizophrenia, as Carrie mentioned, is we're collecting this broad range of data types. And it may be that the relative contribution of these different data types for predicting transition varies based on this mode of psychosis onset. They may carry a different predictive weight depending on the type of transition we're talking about. And this is just speculation, based on my part, but it's possible that for the subtype that's reasonably stable, the green line here, and then deteriorates, the progressive biological change may be more predictive. So these data types on the left may be more useful for that purpose, whereas for the subtype that shows initial improvement and then the sharp deterioration, the red line, there may be a greater contribution of psychosocial environmental factors such as stressful life events against a background perhaps of biological vulnerability. So the data types on the right might carry more weight in terms of prediction models for these cases. And this is, of course, an oversimplification of the scenario, but it's just a heuristic to get this concept across. And then the sharp deterioration we see in the red line, those red cases about 75 days before transition, raises the question again that Carrie said about the utility of dynamic prediction using the time series data and longitudinal data that we're collecting in AMP schizophrenia. It's plausible that for the sharp deterioration subgroup, there's some sort of trigger precipitating that transition, and the time series data we collect in AMP schizophrenia, some of which is highly granular, with passive sensing and daily surveys, may be useful in identifying that trigger or stressor. So dynamic prediction approaches may be particularly powerful for those sorts of transition cases. However, for the green group with this sort of stable course of symptoms and then a sort of a slow slide into psychosis, they have reasonably severe symptoms at study entry, it may be that baseline data is sufficient for powerful prediction of outcome in that group. I'll wind up here, but And these different types of transitions that I'm talking about may be one reason why many of the existing prediction models in the field have some modest accuracy, because even within these transition cases, we're seeing a fair degree of heterogeneity. These existing prediction models might actually perform more strongly when applied to one subset of these transition cases. And of course, it's difficult to look at that issue because of statistical power issues. But this is going to be one of the great benefits of AMP schizophrenia, getting this large cohort with the multimodal data and the longitudinal data. So we can look at these different types of transitions and the relative contribution of the different data types we're collecting and the utility of static versus dynamic prediction models. Okay, so I'd better finish there, but as others have mentioned, so much hard work has gone into setting up the study so far. So just to acknowledge all the PRESCIENT investigators are putting in so much energy here to get things kicking off. And of course, the project managers and research assistants and other staff working across the research network and the AMP schizophrenia partners and funders. And as Carrie mentioned, it's been, I think a very effective and stimulating collaboration, that's really brought the field together so far. So thank you for your attention. I think it's over to Dr. Shenton now to present on DPAC.
Thank you very much, Barnaby.